Hello everyone. So the next topic which I will be discussing is about the conduction of the nerve impulse. So first we will understand that what is nerve impulse. So nerve impulses, they are electrical in nature. So as you have seen the amazing phenomenon of cloud to surface lightning that occurred when there is a difference in the electrical charge that is being built in the cloud related to the ground. So when the buildup of charge was great enough, there is a sudden discharge of the electricity which occurred. So the nerve impulse is similar to the phenomenon of the lightning that strikes. So both, if I want to compare this, if I want to see the similarities of both of these, then both a nerve impulse and a lightning strike occur because of the difference in the electrical charge, and both result in the electric current. Similarly, a nerve impulse is like the lightning strike, which is an electrical phenomenon. So a nerve impulse occurs because of the difference in electrical charge across the plasma membrane of a neuron. So this is the basic definition of the nerve impulse. Now, the conduction of nerve impulse occurs in two steps, that is the resting potential and the action potential. So this is a diagrammatic representation of the resting potential. Now what this figure is showing to you? This figure is showing the sodium potassium pump which is maintaining the resting potential of a neuron. There is more negative charge which inside than the outside of the cell membrane. So as you can see here also, there are, you can see here that there are more of a negative charge inside than that of the outside of the cell membrane. So ATP, there is a ATP which is being used to pump sodium out and potassium into the cell. So there is more concentration of sodium outside the membrane and more concentration of potassium inside the cell due to the unequal movement of these ions and the pump. So there is an unequal movement of these ions and pump. So what is happening in this? When a neuron, it is not actively transmitting a nerve impulse, it is in the resting state. So what is the resting state of the nerve impulse? It is when a neuron, it is not actively transmitting a nerve impulse. So what is happening during the resting phase? So in the resting phase, as shown in the previous diagram also, there is a sodium potassium pump which maintains the difference in charge across the cell membrane of the neuron. So the sodium potassium pump, it is only the mechanism of the active transport that moves sodium ions out of the cells and potassium ions into the cells. So the sodium potassium moves both ions from the areas of lower to higher concentration using energy in ATP and carrier proteins in the cell membrane. So sodium, what is sodium? Sodium, it is the principal ion in the fluid outside the cells, and potassium is the principal ion in the fluid which is inside the cells. So these difference in the concentration create an electrical gradient across the cell membrane that is known as the resting potential. So tightly controlling membrane resting potential, it is critical for the transmission of the nerve impulse. So this was. Now what is an action potential? An action potential, also called as a nerve impulse, which is an electrical charge that travels along the membrane of a neuron. It can be generated when a neuron's membrane potential is changed by chemical signals from nearby cells. So in an action potential, what is happening? In an action potential, the cell membrane potential changes quickly from the negative to the positive as sodium flows through the cell into the cell through ion channels while potassium flows out of the cell. So there is is a graph which is depicting the action potential, the resting potential, and is a time which is being given. So whenever there is a change in the membrane potential, it will result in the cell which is becoming depolarized. So an action potential works on all or nothing basis. That is the membrane potential that has reached to a certain level of depolarization, which is called a threshold. Otherwise, an action potential will not start. So this threshold potential varies, but is generally about 15 millivolts, which is more positive than the cell's resting membrane potential. So if a membrane depolarization does not reach the threshold level, an action potential will not happen. So the action potential will not happen. So if I talk about the first channel which open are the sodium ion channels, which allow sodium ions to enter the cell. So the resulting increase in positive charge inside the cell starts the action potential, and this is called the depolarization of the membrane. Then potassium ion channels then open, allowing potassium ions to flow out of the cell, which ends the action potential. So the inside of the membrane becomes negative again, and this process is called as the repolarization of the membrane. Now both the ion channels then close, and the sodium potassium pump restores the resting potential of minus 70 millivolts. So the action potential will move down the axon towards the synapse like a wave. So it is moving towards the negative part like a wave. So the nerve goes through a brief refractory period before reaching the resting potential. So during the refractory period, another action potential cannot be generated. So this was all about the conduction of the nerve impulse. These are some of the references. Thank you.